Okay, so we're going to be making the molecules that Dr. Denning talked about in his video so that we can see how the molecules that we find in our atmosphere actually contribute to being greenhouse gases, whether they are greenhouse gases or not, depending on how they move and how they vibrate in order to be able to take that infrared energy that is radiated from Earth into our atmosphere and re-radiates it back to our environment. So we're going to start by using pipe cleaners. These are going to be our chemical bonds. And to take pipe cleaner, twist it around, and make our chemical bonds. Now that we have all of our bonds made for our molecules, we're going to take styrofoam balls that I've pre-labeled with either a C for carbon, an N for nitrogen, H for hydrogen, or an O for oxygen. And we're going to start building these molecules that we see in our atmosphere. Again, nitrogen, oxygen, carbon dioxide, methane, water, and nitrous oxide. So I'll show you how we're going to build them. Okay, for nitrogen, you'll see this on your chart that you have in your work today that you'll be filling out. It has a triple bond with 2 nitrogen atoms. I'm going to build our nitrogen molecule. And there you have your nitrogen molecule. And I'll go ahead and continue on with the rest of these to build the rest of the molecules of gases that we see in our atmosphere. Okay, so here's all of our molecules. We have nitrogen, we have oxygen, carbon dioxide, methane, water, and nitrous oxide. Just by looking at these molecules, can you make a conjecture as to which ones do you think will have a lot of movement and which one or ones will vibrate the most? When you look at your worksheet today, and your worksheet is going to look something like this, you're actually going to be circling, and you can see your choices in your multiple choice selection, which isn't on this form, but it is in yours, where you're going to be circling which ones have little movement, some movement, lots of movement, a lot of vibration, or no vibration or little vibration. So as we go down through these molecules, watch the video and then go ahead and circle what you think you see happening. Okay, so when I start moving the nitrogen molecule, you're going to observe again whether there's lots of movement, little movement, some movement, lots of vibration, or little vibration. So I'm going to go ahead and start shaking these. What do you notice about this molecule? Alright, I'm going to repeat the same thing with our oxygen molecule. This one has a double bond. What can you say about its motion? Okay, here's carbon dioxide. What do you notice about its motion and its ability to vibrate? And if I were to hold this here in the middle, what do you notice? Okay, and this is methane. What do you notice about methane? Kind of clumsy to hold. If I was just to take the hydrogen molecule, what do you notice about methane? Okay, next is water. What do you notice about water? Lots of motion, little motion, lots of vibrating, little vibrating. And finally, nitrous oxide. What do you notice about nitrous oxide? This one you can actually observe the double bond side versus the single bond side. So So again, you're going to go back, and if you need to, replay this video to look again at all of your molecules to see what type of movement they had, what type of vibration they had, and circle them on your worksheet. And then finally, as you look at this experiment, go ahead and think about what Dr. Denning said in the video. The ones that vibrate the most, the ones that move the most, are the gases in our atmosphere that would be considered our highest greenhouse gases. So based on what you observed today, what would those gases be? Would it be nitrogen? Would it be oxygen? Would it be carbon dioxide? Would it be nitrous oxide? Would it be water? Would it be methane? Which ones have the most movement and which one have the most vibration? Because those are the ones that are going to be your greenhouse gases.